Hi guys, welcome back. We are doing another stoichiometry walkthrough. We're going to practice some problems together so that way you can use it as a reference when you are studying or doing some homework problems. We're going to go ahead and start with this first problem out of 6. Our first couple problems are just dealing with moles, so we will not have to do any conversions, just some calculations. Our first question here is asking how many moles of CO2 are produced from the combustion of 6.40 mole of C3H8. So our very first step, we're going to take this piece of information right here, our 6.40 mole, and we are going to jot that down. So it's asking me how much CO2 is going to be produced if I have 6.40 mole. So we have to look at the ratio of moles in the equation above. So our normal ratio would be 1, there's an invisible 1 right here, to 3. So for every 1 C3H8, we get 3 CO2. We're going to go back down here and click on this again. We're going to go ahead and set up the rest of our equation. So we know that we are going to end up with 6.40 mole of C3H8. Then we're going to set up our unknown moles over our known moles. So what we don't know is how many moles of CO2 are going to be produced. So our CO2 is going to go on the top. In our ratio, it's 3 to 1, so we're going to put 3 mole of CO2. On the bottom of that ratio, we're going to put our known moles. So in this equation, we know how many moles of C3H8 we're ending up with, so that's going to go on the bottom. In the ratio, the formula, it is again 3 to 1, so we're going to put 1 mole of C3H8. We are going to go ahead and multiply that out. If you plug that into your calculator, you should end up with 19.2 mole of CO2. And if I go back to my problem, because we always want to go back and make sure we're actually done, it's asking me how many moles of CO2. So I go back down here and I check that I have moles and that it's CO2. And now I know that I'm done with this problem. We're going to go ahead and start number 2. Again, these problems, we are just focused on moles, so there's no need for conversion, and we're just going to jump right into it. So this question is asking us how many moles of CS2 forms when 2.7 mole of carbon reacts. So first, we should always check that our equations are balanced. A quick glimpse over this equation will tell us, yes, that it is balanced. So we can go ahead and start solving. So in part A here, we are looking at how many moles of CS2 form when 2.7 mole of carbon reacts. So we have 2.7 mole of carbon, and we want to know how many moles of CS2 we're going to get. So we have to set up our ratio. We're going to put unknown moles over known moles again. So our unknown here is the CS2. If we go up here and we look at our chemical equation, we can figure out our ratio. So for every 5 carbon, we get 1 CS2. If I go back down to my equation, I can then set it up with 1 mole of CS2, because that's our unknown. That's what we want to figure out, over our known, which is carbon. So 5 mole carbon. That is our equation that we're going to use. So we can go ahead and plug that into our calculator. And we're going to end up with 0.54 mole of CS2. Again, I want to make sure that I'm actually done with my problem. So I can go back and see, okay, it wants me to find moles of CS2. And I can look down here, see that I have moles, and see that it's CS2. And I can say, alrighty, I am done. Now this one's a two-parter, so we'll jump down to part B. It wants to know how many moles of SO2 are required to produce 118 mole of CO. So we have 118 mole of CO. We want to know how many moles of SO2 are going to be produced, so we have to set up our ratio. We'll use a different color for this one, just to avoid any confusion up here. So we're looking at SO2 and CO. And that ratio is going to be 2 to 4. So I'll jump back down to my equation here. We're going to put our unknown moles on top and our known moles on the bottom again. We want to know how many moles of SO2 we have, so that is our unknown. So I'm going to put 2 mole SO2 over our 4 mole of CO. And like we did before, we can plug that in to round off our calculations. And we should get 59 mole of SO2. Like we always do at the end, I'm going to look back at this and see that it wants moles of SO2. I'm going to see that I have mole and that it's 4 SO2. And now I know that I'm done. We're going to jump into number 3. Again, this is another one of those where we're still staying in moles. We won't have to convert. This question says, lithium and oxygen react explosively to form lithium oxide. Write a balanced, that should say equation, for this reaction. Then calculate how many moles of lithium oxide will form if 1.68 mole lithium are reacted with the oxygen. So I've already gone ahead and written that formula here for us just to save some time. And we'll hop right in to the meat and potatoes of it. So we want to know how many moles of lithium oxide will form if 1.68 mole lithium are reacted. I have to make my box again here. So we have 1.68 mole of lithium, and we'll set up our ratio. So again, it's unknown moles over known moles. In this situation, we want to know how many moles of lithium oxide will form, so that is our unknown. So if I look over here at our ratio, lithium oxide and lithium, that is a 4 to 2 ratio. So now I know what my numbers are. I can pop back down here. Again, lithium oxide is our unknown. That's going to go on top. So I can say 2 mole of lithium oxide. And on the bottom, I can say 4 mole of lithium. We're going to plug that in, chug it out on our calculator, and we should end up with 0.840 mole of lithium oxide. Like I always do, I'm going to take my little green pen here. I'm going to pop up back to my question, see that it's asking me for moles of lithium oxide. And if I go back to my answer, I have moles of lithium oxide. So I know that I am done. We're going to pop on to number 4. Now, number 4, we are going to start having to convert things because now we're going from moles to grams, and we're not just sticking in that range of mole units. So we're going to have to do some calculations and some conversions here. This question says, write a balanced equation for the double replacement reaction between barium acetate and potassium phosphate. I went ahead and wrote that balanced equation out to save some time. Part A is asking us if 4.36 mole of potassium phosphate react, how many grams? See, we have different units there. It's giving us moles, but we want, let's do yellow instead, grams. How many grams of barium phosphate are produced? So we're going to tackle this in different steps. I think it makes it a little bit easier to break it down as opposed to setting it up in one long go. So the first thing that we're going to do is convert from, not convert. We're going to set up our ratio. After we do that, then we'll convert into grams. So we know that we have 4.36 mole of potassium phosphate. So that our potassium phosphate is going to be this K3PO4. That's our potassium phosphate. Our barium phosphate is this bad boy right here. So I have 4.36 mole of my potassium phosphate. I want to figure out how many grams of barium phosphate are produced. But first, I'm going to need to figure out how many mole of that are produced. So we can go ahead and set up our ratio just like we did on the other slides. It's going to be our unknown over our known. So our unknown, and this is our barium phosphate. If I look at my equation up here, that is a 2-to-1 ratio, right? Because we have an imaginary 1 in front of our barium phosphate. So I'm going to go ahead and plug that in. So I have 1 mole of barium phosphate. So Ba3, that is not a 3. PO4, 2. So that's our unknown. We know we have 4.36 mole of potassium phosphate. So in our ratio, that one's a 2, that one's going to go on the bottom. So I'm going to say I have 2 mole of potassium phosphate. Okay. Now we can go ahead and plug that into our calculator as per usual. And we are going to end up with 2.18 mole. Now this is of barium, if I can type it out again, phosphate. So I'm going to take my little green pen, right? And I'm going to look here, and I'm going to look back at my question. So it says, if 4.36 mole of potassium phosphate react, how many grams of barium phosphate are produced? So I have the barium phosphate part, but I don't have grams, I have mole. So that tells me that this is not my answer, and I need to keep going. So our second part, we need to convert that value into grams. So I need to know my molar mass to be able to do this. I've already gone ahead and calculated that out for us just to save some time. But essentially, when you calculate molar mass, you are adding up the atomic masses of the individual elements and their appropriate ratios to get your total molar mass. So up here on my blue sticky note, we know that our molar mass is 601.93 grams per mole. I am going to take the amount that we just calculated, our 2.18 mole, and I'm going to multiply it by that molar mass number. 601.93 grams per mole over 1. If I calculate that out, I'm going to end up with about 1,312 grams of barium phosphate. I can get my little green pen again, and I'm going to look at my question. It wants grams of barium phosphate. Guess what? I have grams of barium phosphate, so I know that I'm done. Jumping into number 5, this one is another two-parter, and we will just start with part A. So we have this question. It says, how many grams of magnesium chloride are produced by 2.55 mole of magnesium? So let's just get started. Also, you'll note on this one that I went ahead and calculated molar mass ahead of time as well. So we have 2.55 mole of magnesium. We want to know how many grams of magnesium chloride are being made. First, though, we have to do the ratio in moles because the ratio in the formula is in moles. So we have to do that before we can go ahead and convert it. If I look at my chemical equation up here, I can see that the ratio between magnesium and magnesium chloride is 1 to 1. And that makes our lives pretty easy, but we're still going to go ahead and type it out. Putting our unknown on the top, so that would be our magnesium chloride, over our known on the bottom, which is our magnesium. Now, that one's pretty simple. You probably don't need to plug it into your calculator, but we're going to get a 2.55 mole of magnesium chloride. So let me make this a little bit smaller. There we go. I'm going to take my green pen and I'm going to check my question like I always do. How many grams of magnesium chloride are produced? Well, I have magnesium chloride, but guess what? I don't have grams, so I'm not done. We are going to use the molar mass that I've already calculated to convert this from mole to grams. So my 2.55 mole of magnesium chloride. And I'm going to multiply that by our molar mass, which is 95.211 grams per mole. 2.1 over 1. And this is going to give us 243 grams of magnesium chloride. Now I'm going to take my green pen again. I'll look back. It says grams of magnesium chloride. And down here, I have grams of magnesium chloride. So I'm done with part A, and that is my answer. Popping down to part B, it's asking if 2.26 moles of hydrochloric acid are reacted, how many grams of magnesium were used in the reaction? So we're starting out with moles, and again, we want grams, so this is going to be very similar to part A. We know that we have 2.26 moles of hydrochloric acid, or HCl. And we want to know how many grams of magnesium were used, but like in the first one, we have to solve the ratio in moles first before we can convert to grams. So I'm going to grab a different colored pen. We'll do blue. That way we don't get confused. And we'll look at our ratio up in our chemical equation. So we're looking at HCl and magnesium. So our ratio is 1 to 2. And we're going to put our unknown on the top and our known on the bottom. So our unknown is magnesium, so 1 mole of magnesium on the top. And on the bottom, we have 2 mole of hydrochloric acid, or HCl. So if we go ahead and plug that into our calculators and figure that out, we're going to end up with 1.13 mole of magnesium. like I always do, I'll take my green pen and I'll go ahead and check my question. It wants moles, excuse me, not moles, it wants grams of magnesium. I have magnesium, but again, we're in moles and not in grams, so I'm not done. I have to now convert my moles into grams. So using my 1.13 mole of magnesium, I'm going to multiply that by our molar mass that we already solved for, which is 24.305 over here on my blue sticky note, over 1. And that is going to give us about 27.5 grams of magnesium. So I'm going to grab my green pen. I'm going to look at my question, grams of magnesium. I have grams of magnesium here, so I'm done, and this is my answer for part B. Keep in mind that as we're working through these, sometimes the values I have for things may be slightly different from values you end up with, and that's all depending on what resource you're using to calculate your molar mass. Some periodic tables, the atomic mass of the elements are going to vary slightly from each other. It may be like 1 decimal off, and so the final answer we get may be 1 decimal off, but as long as it's in, you know, a close range, we're still okay. If you're getting something like 97 when the answer is supposed to be 27, obviously something's wrong. But if you're getting 28 and I get 27.5, we're still on the right track. All right, let's go ahead and wrap up with question 6. So question number 6, we are converting again, but this time from grams to moles instead of the other way around. So these ones are also going to have 2 parts to them, just flip-flopped from what we were doing. So part A says if 32 grams of CaC2 are used in this reaction, how many moles of calcium hydroxide are produced? So our calcium hydroxide, it's talking about this guy right here. We are starting off with, there we go. We're starting off with grams, but our ratios are in moles. So before we do our mole ratio, we're going to have to convert from grams to moles. In our last slide, we did the conversion after, but because this is flip-flopped from what we were just doing, we're going to do our conversion first. So we need to get our CaC2 from grams into moles. So I have 32 grams of CaC2. I want moles. If I have grams and I want moles, I need to multiply my known grams times 1 mole. I cannot type today. Over our molar mass. I've already calculated for us our molar mass of CaC2 is 64.099 grams per mole. So we can go ahead and plug that in. And we should end up with 0.499 moles of CaC2. As always, I'm going to take my green pen. I'm going to look at my question. We want moles of calcium hydroxide. So I have moles, but this isn't calcium hydroxide, so I'm not yet done. We're going to go ahead then and figure out how much calcium hydroxide we would make with this given amount of CaC2. So our given amount of CaC2 in moles is 0.499 mole. And we're going to go ahead and set up our ratio just like we did earlier. So if I look up here, we have CaC2 and calcium hydroxide. This is a 1-to-1 ratio because remember in front of these we have imaginary ones. So if I click on here, I have 1 mole of my unknown, which is CaOH2, our calcium hydroxide, over 1 mole of my known, which is CaC2. Now, you probably don't need a calculator for this one. It's going to end up being the same answer because it's nice and easy and we have that 1-to-1 ratio. But we still want to work it out anyways so that we get the hang of this and we get practice. All right, so our answer should still be 0.499 mole, but now of calcium hydroxide. I'm going to get my green pen. I'm going to check I want moles of calcium hydroxide. And here I have moles of calcium hydroxide. So I know that this is my answer and I am done. Coming down to part B, we're going to see how many moles of water are needed to produce 56.8 grams of C2H2. Much like in the first part of this question, we are going from grams to moles. And we're going to do that conversion first because when we work with our ratios, it needs to be in moles. So we have 56.8 grams of C2H2. And we want to convert that into moles. So using our formulas up here, we have grams, our given grams. We're going to multiply that by 1 mole over our molar mass, which for C2H2 we've calculated is 26.038. If we go ahead and plug and chug that into our calculator, we're going to end up with 2.181 mole of C2H2. Now with my trusty green pen, I'm going to check. We want moles of water. I have moles, but this, my friend, is not water, so we are not done. Now we can start working on our ratios to see how much water would be produced with this amount of C2H2. So with this amount of C2H2, 2.181 mole, we can start setting up our next calculation. We're going to look at our ratios again. I'll use blue to differentiate. We're looking at water and C2H2. In this question, or part of the question, we have a ratio of 2-to-1. So now I can continue filling this out. And remember, our unknown is going on top, our known is going on the bottom. So in this instance, we know how many moles of C2H2 we want to end up with. So that one's going on the bottom, and our moles of water are going on the top. Our ratio again is 2-to-1. So we're going to have 2 mole of H2O over 1 mole of C2H2. We're going to plug that into our calculator and chug along. And we should end up with 4.36 mole of H2O. Last step, I'm going to grab my green pen and I'm going to check. It wants moles of water, and look what I ended up with, moles of water. So this is my answer, and I am all done. See you next time.